Alright, well, I think this is going to be my last video for this series. Kind of final update in a sense. Might as well have something printed in the background. That sounds like fun, right? Well, let's see. For starters, the guys at Folger Tech, they 2-day priority mailed the missing parts to me from New Hampshire down here in Florida. Or to me down here in Florida. So, I got all the things I need. Again, I kind of jumped the gun and went and bought all the pieces I needed anyway, or made some things fit. But the poor printed parts, they sent me new ones. That was kind of them, and as well as the missing bolts and the threaded rod. So they're good guys. Certainly not going to speak ill of their kit. I'm sure it was just a little accident or something in the assembly line process of assembling the hardware kits, perhaps. But nothing against them. I got some really great prints for a while using ABS, which is great because I got to take advantage of the heated bed. And then kind of ran out of a small spool ABS, went back to PLA. That's what's printing now. And strangely enough, as soon as I switched over to PLA, I had all sorts of problems. I was losing steps on my X-axis. Let's see what else. Yeah, that was the big one. I was losing steps. And as things were getting a little warmer than they should, motor-wise, and they're a little noisy. So, turns out what I needed to do is I had to give more voltage to the X-axis stepper motor. That was part one of it. That helped. But then I started noticing a squeal. I was like, oh, what's the squeal coming from? Turns out, and I said it in an earlier video, that the over here, there's a bearing with kind of a keeper bushing, if you will, around it that goes into the end idler on the X-axis. And I said that was tight. Well, it turns out it was too tight. And what that was doing is it was causing a lot of resistance, and ultimately the squeaking noise that I was hearing was the belt slipping over that idler pulley instead of spinning it around. And that's no good. So while it was still working, sort of, I printed out a new one. You can see a little white piece in there, perhaps. I probably could have just sanded the part that they gave me down a little bit to make it a little bit narrower. I also encourage everybody to consider using powdered graphite when plastic parts rub against other plastic parts. Can't hurt anything. Probably would warn against using like a silicone spray or something. The exception being maybe if you choose to, even though I don't think I need to, you might put some silicone spray on the smooth rods for your bearings, but that's metal on metal, and that's totally different than plastic on plastic. I think I did say, or if I hadn't, I did get the little LCD screen and card reader. If you can get that for cheap, I think I paid $13 and that included shipping from China. I encourage it. It's a nice little add-on, especially for telling your temperatures, and gives you a couple of manual controls, which is really nice. Tools-wise, again, they were pretty generic when they said you need tools for this. You need a fair amount of them. 7/32 inch socket or nut driver. 13mm ratchet, possibly. Certainly need a 13mm box wrench. I encourage channel locks or adjustable plumbing pliers. You need wire strippers, wire cutters. Certainly, if you can, invest in an inexpensive but accurate digital caliper. You'll need that when it comes time to calibrate this thing so that you're getting accurate prints. Screwdriver, of course. Soldering iron. Since you're getting the heated bed, you're going to have to do some soldering to the heated bed for the thermistor, excuse me, and the power leads for that. I also did break off my power leads, so make sure they're coming out the back nice and straight, or front nice and straight, and that there's not a lot of bending right at the solder joint, because I'll just break them. Let's see, what else? Oh, I had to use a crimp connector tool and the forked, the fork style terminals so that I could get my power connectors and all that to go onto the power supply nicely. So I did clean it up a bit. Also, like you've seen before in previous videos, I did invest in some loom. That's good. If you really want to go crazy, they make cable path chain or something like that. That's some pretty cool stuff. I think you can print it out yourself if you want to take down on that task. Otherwise, it's working as it should. Oh, I also did insulate the heated bed, since I'm looking at it. You can see there's 2 layers of cardboard underneath here. I had to use a hole punch and punch out anywhere that one of the bolt heads stuck through for the bearing holders. I also, there's, like I said, 2 layers. On the upper layer I did make one hole for where the thermistor, the little itty-bitty surface mount component on the underside is, so that that's not just pushing into the cardboard. I think that's it. Again, this thing is pretty cool. The part I'm printing out right now is actually one of many of the upgrade kit for a 2-up 3D printer. When I won this kit, turns out I also won another kit on eBay that wasn't complete, or at least wasn't tested. I know that the 2-ups and the 1-ups have got a really bad reputation for sagging, but since I have a working printer, I can print the parts to fix that, so that's what I'm going to do. So who knows what I'm going to do with 2 printers. I do know there's enough components in the 2-ups that I could make a Delta type printer by just investing in some of the framing and a couple of belts and pulleys. So that could be a nice use of that. But the 2-ups and the 1-ups were about the cheapest thing going during their Kickstart plan. And they were back ordered a lot, and a lot of complaints, and then when everybody got them, they weren't happy because they were printed out of MDF, so that's wood, by the way. So, I'll get it, I'll try it out. It's supposed to have good accuracy, even though everybody complains it doesn't. So I'm thinking with these other parts I'm going to print for it, I might be able to get it either dialed in, or if not, I'll scrap the pieces from it, or strike the pieces from it, and build another printer. But you guys have a good one, and enjoy this whole series of videos, especially if you bought this kit directly. For the price, I don't think you can complain too much, and it's pretty darn accurate. I will show you the one thing that I did. Everybody does one of these, but I was pretty happy I got mine printed within a week of getting my printer working, because I got it dialed in. I'm going to move the camera back here. You guys have seen these cubed gears. Well, I just printed these off a couple days ago, and didn't have to do any modifying to it, as is, came right off the printer bed. But these things are cool. So yeah, if my tolerances were way off, there's no way this thing would work. I also printed one of the, what is that, the herringbone gear sets for extruders, and that came out pretty accurately as well. And that was an ABS, so I felt that the printer was pretty dialed in at that point to take on this little task. This was a 5-hour print, however, but it is pretty cool. I did get a touch of separation between the layers on the inside piece, and that's just trying to get fine-tune the temperature settings on the filament, but I've depleted my little spool of this anyway, so I get to play with it all over again, or try to figure it all over again with the next spool of ABS. PLA is a little simpler to dial in. But alright guys, I hope you get one of these kits. I hope you put it together. I saw that Folger Tech on eBay they had like 102 kits and they've already sold 75 of them. I got one. Not bad for under 100 or 350 shipped. And with these videos I made and the videos they provide on their Google Drive, it can be done and have a lot of fun with it. Alright, signing off.